Hello there. Welcome to this edition of our learning. Today we will have to look into mathematics past question, specifically for BECE exam, Basic Education Certificate exam. Okay, so today we are going to look at mathematics, and we're going to look at the past question of 2023. Okay, and on this particular class, we'll look at the paper 1. You know, your basic question has paper 1, paper 2, and paper 3. All right? So today we will look at paper 1. We will have to solve every question from number 1 to 60. Okay? We'll solve them, we'll look at the answers. Okay? I'll give you a guide on how to solve the questions. I'll give you a guide on how to approach the questions and how to arrive at the correct answers, okay? So if you're ready, let's go to our app. You can open to your BECE Mathematics, okay? Go to Mathematics 2023, paper 1, okay? And make sure it's not on shuffle so that you follow the questions accordingly, all right? All right, so let's get started. Okay, so the first question we have here is, what is the square of 30? What is the square of 30? So we have, the square of 30. So the square of 30, we have number 1. What is the square of 30? So we have a question mark there, solution. So this is something that you should know how to solve. We'll have to look for the square of 30. The square of a number is that number multiplying itself, okay? So square of 30 is equals to 30 square. 30 square. All right, and from our law of indices, this in expansion form means 30 times 30. Is that okay now? So this will give us about 900. How did we get to that? That is 30 times 30. All right, 0 times 0 is 0. 0 times 3 is 0. 3 times 0 is 0. 3 times 3 is 9. So once we add everything together, we arrive at 009. So our answer is 900. So if you look at your option, we have option E as the correct option. Okay, so let's move to the next question. Is that okay now? So the next question says, okay, said find the square root of 75 over 300. So number 2, I won't write the questions down because I believe you are checking through your app, okay? So you just get the questions from there, all right? So, but the question says, find the square root of 75 over 300. So the first question we did was on square, now is square root. So square root is just simply to square root 75 over 100. So we're going to do 75 over 100 all in a very big square root like this. Is that okay now? Now, square root of any number will give us an answer that when we multiply that answer together, it will give us that number. Is that okay? It's the root of that number. Okay? So now, we know that numbers that have square roots, okay, should first of all be perfect squares. Do you understand the point now? But you can see that 75 is not a perfect square. 75 does not have a number that when it multiplies itself, it gives 75. For example, okay, 4 is a perfect square. Okay, 4 has a square root. If you multiply 2 and 2, 2 times 2 is 4. Okay, 16 is a perfect square because 4 times 4 is 16. 25 is a perfect square. 5 times 5 is 25. 9 is a perfect square. 3 times 3 is 9. So those So those are what can give you a square root. Do you understand me? When you square root a perfect square, it gives you the number that multiplied itself together to give itself. Do you understand the point now? So what it means is that 75 is not, sorry, this is 300 rather. 75 is not a perfect square. 300 is also not a perfect square. There is no number that when you multiply them together, like same number multiplied by itself will give you 75. No number. Do you understand that now? No number also can give us 300 when you multiply itself. So what do? We have a problem here. What we can do is simply expound 75 such that it can have a part of it as a perfect square and a part that when it multiplies that perfect square, it will give 75. For example, if we look at 75, we will know that 25 times 3 will give us 75. Hope you know that it is still under the square root. You see? So 25 times 3 gives us 75. What I'm saying is that now 25, because it is a perfect square, let's try to introduce a perfect square 25. So 3 is not, so let's just keep it there and see what magic we can do. Do you understand the point now? All right. So the next thing is for 300, 100 is a perfect square. So 100 is a perfect square times 3 also, because 100 times 3 gives us 300. So this thing and what we have here is still the same expression. Do you understand the point now? Now, you see, here we have 3 and we have 3. So this 3 can actually, do you understand the point now? Okay, can do that. So what we'll now have is equals to 25 over 100 square root of these things. Do you understand the point now? So, which is now square root of 25 is equals to 5. Square root of 100 is equal to 10. Do you get the point now? Then, 5 into itself is 1. 5 into 10 is 2. Do you get the point now? So, if we look at our option there, we'll see that option A is our correct option there. Now, we can also, if we don't want to use this step, if it will be too ambiguous for us, simply, what we can do is 75, okay, root of 75 over 100, over 300 rather, over 300, okay? We can just simplify, okay? We can bring these two to their lowest terms. We'll bring them to their lowest term to a point that we can now have perfect squares as their lowest term. For example, a common factor we have for 75 and 100 is 5, okay? 5 into 7 is 2. That is 5 divided 75. Now, 5 into 7 is 2, okay? Now, that will be remainder what? 2. 5 into 7 actually is 1, okay? Now, remainder what? 2. We put that 2 here. We put that 2 here, it becomes 25. 5 into this 25 will be, 5 into 25 is going to be 5. You see that now? The 5 into 300, 5 into 30 is going to be 60. 5 into 30 is going to be 6. Then plus it, so it's 60. Now, if we have this kind of thing here, we can still go ahead, okay, to say 5 in 15 is 3, okay, 5 in 60 gives us 12. Do you get the point now? Now, we can still go ahead and 3 here is going to be 1, 3 here is going to be 4. Do you see what is happening there now? Now, root of 1 is 1 because 1 times 1 is 1. Do you understand it? But why I didn't go through this process? It's a longer process. The root of 1 is 1. So square root of 1 is 1. That is 1 times 1. You know, the square of a number is that number multiply itself. So the root is that number divided by its number that made it a perfect square. So the square root of 1 is 1. While the square root of 4 is 2. So it still gives us the answer that we got here. So whichever method you want to use, we will all arrive at the same answer. So let's go to number 3. So the next one Number 3 says express 61,782. They said we should express this in standard form. Okay? All right. So what we simply do, standard form, of course, there will be an introduction of this number such that it is multiplied by a number that is raised to the power of, that has 10 raising to the power of any number according to the number of the decimal point where we have it, okay? So what we have there is, to convert this to decimal, to a standard form, remember every natural number has a decimal point at the end of the number. It means 1, 2, 3, all those numbers, they have point at the end of the number. For example, if I give you a number like 1, this means 1.0. Okay? If I say 2, 2 means 2.0. So if you write 1.0, you are still saying the same thing as 1. If you say 2.0, you are saying the same thing as 2. But why would you want to waste your time in writing 1.0 when you can just write 1? So that is why we'll just leave those numbers like that, okay? If not, all natural numbers that doesn't have decimal, you can't see decimal, they have a decimal point at the end of those numbers. Is that okay now? So it means that 61782 has an invisible decimal point here. Is it okay? Is that okay now? So this 0.0. So our problem here is removing this decimal point to where we should have what we have in the options there. Do you understand the point now? You can take this decimal point to anywhere. If you take it down here, that can still be in standard form. You can decide to take it here, it will be in standard form. But where you should be concerned to take it to is where you have in your option. What you have in your option. Okay? What you have in your option is all the numbers you have there have the decimal point immediately after 6. So we are going to take this decimal point to where we have 6. So you count the number of times this number will move to where we have 6 here. So this number will move 1, 2, 3, 4. Is that okay now? Now, when we are counting backward, okay, in standard form, when we are counting from the right to the left, our exponential, okay, our index, okay, is always positive. But when we are counting from left to right, it is negative. Is that okay now? So because we are counting backward, so this will now be 6 point. Remember, this decimal point is off here now, is now here. So it will now be 6 point, every other thing here. 1, 7, 8, 2 times 10 raised to power 4. Do you get the point now? Times 10 raised to power 4. Why did you put 4? Because it moved how many times? 1, 2, 3, 4. Do you understand the point now? So if we look at our options, option E is the correct option there. All right? So let's move to number 4. Number 4 says express 0.00307 0.00307.5. 0.00307.5. They said we should express this number to 3 significant figures. All right. If you have been following this channel, if you have been following our classes here, we have learned estimation and approximation, okay? And we have talked about what a significant figure is, okay? A significant figure is a number that is significant, that has a value that it is playing, or a role it is playing in a set of numbers. Do you understand me? All right, so we have said that 0 is not a significant number because it is almost valueless on its own, like 0 is nothing, okay? So, but we said that the only time 0 becomes significant if it is in between 2 significant numbers, Do you understand the point now? So significant numbers are numbers from 1 to like 9. Do you understand the point now? 1, 2, 3, 4, 5, 6, 8, 9. So if we have 0 in between any of these numbers, okay, 0 becomes significant. But if 0 is at the end of any set of number or at the beginning of any set of number, that 0 is not significant. So what it means is that all these things, 1, 2, 3, they are not significant. So the significant numbers I will have here is 1, 2, 3, 4. So on its own, these numbers here, this number here is a 4 significant figure. Do you understand the point now? This 4 significant figure. Do you understand me now? All right. So although it is not 4 digits, there is difference between the number of digits and the number of significant figure. Do you understand the point? So this 1, 2, 3, 4, 5, 6, 7. This is 7 digits. Do you understand me now? All right, but the significant figure is just 1, 2, 3, 4. What made 0 significant is because it's between 3 and 7, which are significant numbers. So they are asking us to correct or express this number now to 3 significant figures. It's just to approximate, okay, round off 5, take away 5, okay, so that it gives 1 here, and that is it. Remember, we learned round up numbers and round down numbers. Round up numbers are numbers from 5 to like 9, okay, such that they go out, they round off, they go off, but giving 1 to the number behind them, okay. So 5 will go off, but it will add plus 1 to 7, so that this number will now be 0.00308. So this is now 3 significant figures, okay? All right, so the answer is C. Option C is the correct option, all right? So let's move to the next one. Number 5. So let's look at number 5, all right? Number 5 says simplify 7 over 13 divided by 3 over 4. So this on division of fractions, you should be noting this topic so that you know how they occur, okay? So 7 over 13 divided by 3 over 4, okay? All right, so let's go. This will give us 7 over 13 divided by, okay, I know I'm making that long, bigger division, 3 over 4. So this will now be equal to, remember, when we did fraction, we did addition of fractions, subtraction of fraction, multiplication of fractions. You can go back to those videos, those classes, and check them out. We did division of fractions, okay? And we said that when a fraction is dividing another fraction, okay, the denominator, okay, will have to inverse. But before that happens, the division dividing the both fraction changes to multiplication. So what that will mean is 7 over 13 will now be times, this times is this division now that has changed to multiplication. But the consequence of this division changing to multiplication will be that the 3 over 4, the numerator becomes the denominator becomes the numerator. Okay, so 4 now becomes numerator, while 3 becomes denominator. Do you understand that point now? So at this point, we can now have this to be 7 times 4 should give us 28. 13 times 3 should give us 39. So 28 over 39. So option B is our correct option there. All right? All right. Okay, so let's go to the 6th question. Simplify. Okay, simplify 2 over 3. 2 over 3. That is the 6th question. 2 over 3 plus 1 over 5. 1 over 5. This is addition of fractions, okay? When adding 2 fractions without the same denominator, you look for their LCM, okay? So The answer to this is look for the LCM of 5 and 3. Okay? LCM of two numbers that don't have a common factor. A common factor. How to get the LCM of two numbers without a common factor is just simply multiplying those two numbers. Don't go through the process of putting 3, putting 5, then start to do those type of stuff. No, just multiply the two, okay? All right, so 3 times 5 is 15. So that is their LCM, 15. Is that okay? All right, so 5 divide 15 is 3. 3 times 1 is 3. So we have 3 here, plus 3 divide 15 is 5. 5 times 2 is 10. Is that okay now? All right, so this will now give us 13 all over 15. All right, 13 all over 15. And our correct option there is option A. All right, 13 all over 15. Correct option there is option A. All right, let's go to the next one. So the next one says express 108. Express 108 as a product of its prime factors. 108. 108 as a product of its prime factor. So we are going to find the HCF of this, okay? And once we are done, just the way you find HCF, once we are done, then we will now express those prime factors as products, okay? So this is 108. So this will give us 108, 108 will go this way, all right? So 2 is a prime factor of 108. 2 is a prime factor of it. So 2 into 108, so we start by 10. 2 into 10 is 5. 2 into 8 is 4. Is that okay? So we'll go again. 2 is also a factor of 54. So 2 here, 2 into 5 is 2. Remember 1, put it here, it becomes 14, right? 2 into 14, okay? 2 into 14 is 7. 2 is not a factor of 27, right? So 3 is a factor of 27. So we'll go to 3. 3 into 27 will give us what? 9. Do you get that now? So what else again? 3 is a factor of 9. 3 into 9 is 3. What else again? We'll go to 3 again. 3 into itself is this. So we say therefore the prime factors, they say the product of the prime factors. These are the prime factors of 108. Okay, so the product is simply 2 times 2 times 3 times 3. 2, 2, yes, 3, 3, 3, then another 3. So it will now give us 2 raised to power 2 times 3 raised to power 3. That is the answer. 2 raised to power 2, 3 raised to power 3. Option B is the correct option there. 2 raised to power 2, 3 raised to power 3 times 3 raised to power 3. All right. So let's go to the next one. Convert 9 whole number 1 over 7 to improper fraction. So we are trying to convert from what is it called? We are trying to convert from a mixed number to an improper fraction. You can see that these exams can be quite simple to pass. Okay, some of these things are some of those common things you learned in even your primary 6, primary 5, some in your JS1. But you can see them out in your JSS3 exam. So you don't need to take any of these topics for granted, okay? All right, so let's convert 9 whole number 1 over 7. 8. 9 whole number 1 over 7, right? Let's convert it to mixed improper fraction. Do you get that now? All right. So what we do is the denominator multiplied by the whole number, the answer we get, we add it to the numerator, the answer will not be the answer we get divided by the denominator. Okay, so let's go. If we go to 7 times 9, 7 times 9. I've told us before, this big multiplication that you may not be very familiar with the multiplication table, you can do something very simple. First of all, you have 7 times 7 is 49. And you know that you need to go 2 more steps to get to 9 after 7 times 7. You have to have 7 times 8, then 7 times. Do you understand me now? So 7 times 7 is 49. Okay? 7 again times 2 will give you 14. So that 14, you add it to 49. Is that okay now? So it will give you, it will just give you what this answer should be. So this will be, right? This plus this will give us 13. Carry 1, put here, 5 plus 1, 63. So 7 times 9 is 63. Do you get the point now? 63. So 63 plus 1 will give us what? 64 over 7. Is that okay now? There is no need converting to improper fraction because we are just coming from there. Okay, so we have 64 over 7. If you look at what we have in these options, option D says 63 over 7. You may be so confident and you may just think that this is simple. You just do 7 times 9 and you will forget that you need to add the numerator to it and you give your answer as 63 over 7. You will fail it, okay? So you just have to be very careful when solving mathematics questions. So the answer is E, okay? All right, so let's go to the next one. This next one says divide 100, that is number 9. Please just join me, go to your app. I've told you I won't be writing down the questions. The questions are already there in your app, okay? So if you don't have the app, just go to Google Play Store and download it. Then you can contact us for an activation pin, okay? All right, so divide 100 by the positive difference between 65 and 75, okay? So we have 100 divided by the positive difference between 65 and 75. So are we going to do 65 minus 75 or 75 minus 65? Since they said positive difference, okay? Positive difference will mean that the result or the difference should be a positive number, not a negative number. If we do 65 minus 75, it will give us minus something. Do you understand me? But if we do 75 minus 65, it will give us plus something. That is a positive number. So we're going to do, so the difference between 65 and 75, which is positive difference, is 75 minus 65. That is simply what they're asking. Okay? So this will now be equal to, okay, 100 divided by 75 minus 65 will give us 10. All right? So 10, the answer is 10. So, all right. So that is just straightforward. All right? The answer is B, option B. We move to the next. All right? So this one says express 46 in base 8 as a denary. So convert to base 10. That is what they mean. Convert 46, which is a number in base 8, not 46 as per, it's 46, a number in base 8 to a number in base 9 to denary. Is that okay now? So what we do is number 10, 46 in base 8 to denary. So, all right, so we expound this in base 8, then it will give us what we are looking for. So this will mean 4 times 8, all right, plus 6 times 8, all right? So this is 0 and this is 1, all right? Okay, so this will mean, all right, this is anything raised to power 0, we know is 1. We have said that when we did indices, okay? So this will be 4 times 8, this is 32, plus 6 times 8, anything raised to power 0 is 1. So this is 1. All right, so that is 6 now. So this will now be 32 plus 6. That is 32 plus 6. It will give us what? 38. All right, in base 10. Always don't forget to put that. So The correct option there is option B. All right, next one, 11. This says if 30% of a number is 900, find the number. What is the number? All right. Let's see if we can have it here. Number 11. They say 30% of a number is what? 900. So what is the number? 30% of a number is 900. What is the number? This is a simple word problem. Okay, word problem is one of the topics in your exams that you will always see. You will always come across. Okay, so it's good you understand how to apply those principles. So 30%. So 30. This is equal to 30% of means multiplication. A number, we don't know the number. So here, we will even say, the first thing you have to say, or the first thing you have to do is, let that number that we don't know be, let's say, x. Is that okay now? So what they are saying is that 30% of x is means equal to, in mathematics, is 900. So we are going to put everything in mathematical form or in mathematical expression, and we'll get what they are asking us to do. So this means 30% of, in mathematics, means multiplication, times x is equal to 900. So 30% simply means 30 over 100, okay? Times x is equal to 900. That's what they're asking us to do, all right? So 10, this 0 will remove this 0. So we have x times 3. So this is 3x over 10 is equal to 900. Is that okay now? So we are having, this is over 1, cross multiply. So 3x will now be equals to 900 times 10. Is that okay now? We can divide both sides by 3x. Okay? Okay. 900 times 10 is 9,000. Okay? All right. So 3x is equals to 9000. Is that okay now? So divide both sides by 3. That is the coefficient of x, so that we can get the value of x. All right? So this will be divided by 3. Divide by 3. So this removes this. So x will now be equal to 9,000 divided by 3. Okay? Divide by 3, which will give us 3000. How? 3 divided by 9 is 3. So just everything there. So the distance is 3,000. All right? So this is option E. You can get this from here. If we do 30% of 3,000, 30% of 3,000, it will give us 900. That is 3 over 100 times 3,000. Do it there, then post the answer in the comment section. Just do 30 over 10, over 100 rather, multiplied by this value of x, which is 300. It will give you this 900. So the statement is true. All right? Okay, so option E is the correct option. All right. It's number 12. Number 12 says, simplify 2 whole number, 2 over 5, times 1 whole number, 1 over 4. 2 whole number, 2 over 5, 1 whole number, 1 over 4. Simple. Make this one to be an improper fraction first, okay? Convert this to improper fraction. 5 times 2 is 10, plus this is 12. So this is equals to 12 all over 5 times 4 times 1, 4 plus 1. 5 all over 4. Is that okay? So this is the first thing we have to do. So 5 divide itself will give us 1, so we have eliminated that out. 4 into itself is 1, 4 into 12 is 3. So this answer is 3. All right, if you look at our options, option E, excuse me, is the correct option. Option E. So let's go to the next one. The next one says express, number 13, express 0.24 in the form of P over Q. 0.24 in the form of P over Q. Simple. See, these guys can just make you a bit confused, but you don't need to be, okay? This question is a very simple way of asking you to convert 0.24 to fraction. That is to convert from decimal number to fraction, which I know you know how to do it. So, but they now twisted the question, express 0.24, which you know is a decimal number, to P over Q. P over Q is a fraction. So they're asking you to convert it to fraction and keep it in its lowest term. That's what they're asking you to do. So what we do is equal to 0.24, right? Converting to fraction. What do? We move this decimal point to the right so that we can convert it to fraction. Remember, all decimals, okay, are in the base of 100 or in the division of 100 or so, okay? So, depending on, in the division of power of 10, do you understand me now? So, depending on the number of times we move, will determine what value or how many zero will add to 1, okay? So, if we move 1, 2, you get the point. So this thing is not here. So this will now be 24 divided by 100. Remember, if we have, see, just look up here. Let me make an illustration. This is 0.24, right? If we have done just once, it would have been 2.4 divided by 10 because we just moved once. Do you understand the point now? Because if we have it 0.24, and we do nothing about it, this is equal to 0.24 divided by 1. Do you understand? So depending on the number of times we move, it will determine what we will put under it. Do you understand the point? If we have, for instance, 0.245, and we want to take this thing out totally, so this will mean 1, 2, 3. So add how many zeros? 3 zeros. So this will be 245 over 1, then 3 zeros, 1, 2, 3. That is how it works, okay? All right, so that is what this one is now. So they say we should bring it to its lowest term. If you do this, and you look at your options, you will see that you won't find the answer there. So what you will do is to simply do something. 2 into 24, okay, will give us 12 here. 2 into 100 will give us 50. So 2 is still a factor of both of them. 2 here is 6, 2 here is 25. So 6 and 25 does not, 6 and 25 don't have a common factor. So it will now be 6 over 25 as our final answer. So we have expressed 0.24 in the form of P over Q, 6 over 25, okay? So our answer, correct option, is 6 over 25, option D. All right? Okay, let's move to the next. Okay. Find the HCF of 224 and 168. 224 and 168. HCF of 224 and 168. HCF of 224 and 168. 168, 224. So HCF, you know how to do that, right? So bring 168 and 224. All right? So we go down, we go. So HCF. Remember how to go about your HCF. HCF is the highest common factor. Highest common factor. So we must use the factors of the numbers such that the factors we are using must go through the numbers at the same. That's what they say, common factors. Common factors, okay? So if we are using 2, for instance, is 2 a factor of this, is 2 a factor of this. If 2 is just a factor of 168 and is not a factor of this, we can't use 2. So we must use a factor that will be common to both of the numbers we are given to find the HCF. Is that okay now? All right, so let's go. 2 is a factor of the 2 numbers. So 2, we start with 2. Always, it is good at your level, you always start with these smaller numbers. It will help you break these things down very well, okay? All right, so 2 into 168, you begin with 16. Don't go to 168, you may not know what to do. So start with the smaller number. 2 cannot go to 1, that is why we did not even start with 1. If we had 2 here, I would have started with 2, then 6 and 8. Okay, so 2 into 16 gives us 8. 6 into 8, and 2 into 8 gives us what? 4. Is that okay? All right, so let's go to 2 to 2. 2 into 22 or 2 into 2. See that one now? 2 into 2 is 1. 2 into 2 is 1. 2 into 4 is 2. All right, if you add these two things, they'll still give you 2 to 4. So 2 can still go, right? 2 into 84, 2 into 8 is 4. 2 into 4 is 2. 2 into 11, right, is 5. Remember 1. Put it into 2 here, it becomes 12. 2 into 12 is what? 6. You see that? Then the next thing we have to do now is 2 can also be a factor of this, right? So 2 here, 2 in 42, 2 in, what is it called? 4 is 2. 2 in 2 is 1. Right? Then we go to 56. 2 in 56. 2 in 5 is 2. Remember 1, put it here, it becomes 16. 2 in 16 is 8. Now look at, we are going somewhere now. Now, do we have a common factor between 21 and 28? And I think we do. I think we do. Is it 2? No, it's not 2 because 2 is not a factor of 21, but 2 is a factor of 28. You see what I'm talking about now? So you can't use 2. Because 2 is not a factor of 21. It can be a factor of 28. You can only use 2 if you're doing LCM. That is when you can use any factor to make sure that that number reduces to 1. But for HCF, you don't do that. You must use a factor that is common to the 2 numbers or 3 numbers or 5 numbers, whichever number of numbers they give you to do. Do you understand the point? So what about 3? 3 is a factor of 21. Quite all right. But is 3 a factor of 28? I don't think so. 3 is not a factor of 28. Is that okay now? So what do we do? 4 is not a factor of 21. 5 is not a factor. 6 is not a factor, but 7 is a factor of the 2. 7 is a factor of 21. It is also a factor of 28. Is that okay now? So what do? We introduce 7. 7 in 21 gives us what? 3, right? That's 7 times 3 is 21. Then 7 in 28 gives us 4. 7 times 4 is 28. So this gives us 4. So at this point, you can see that 3 and 4, there is no common factor between them. So we will stop at that point. All right? So to find the HCF now is simple, is to multiply what we have here. Whatever answer it gives us is the HCF. So we say, therefore, HCF is equals to 2 times 2 times 2, 1, 2, 3 times what? 7. Is that okay? So we have 2 times 2, 4. 4 times 2, 8. 8 times 7 should be somewhere around 56. All right? 8 times 7, 56. 7 times 7 is 49. Okay? Plus 7. Okay? Gives us 56. All right? So 56 is the answer. So we have option D as the correct option. That is option D. So the next one is 15. This is LCM now. So we should find the LCM of 12, 24, 36. 15. LCM of 12, 24, and what? 36. So let's go. So 2, we do our work here. 2 here, 6. 2 here, 12. 2 here, 18. I believe you know that, right? Okay, 2 again can go. 2 here, 3, 2 here, 6, 2 here, 9. Let's also use 2 because 2 is here. 2 here into 3, it can go, you bring it down. All right? 2 into 6, all right, is 3. 2 into 9, it can go, you just bring it down. Is that okay? Then 3, let's bring 3 down. 3 into itself, 1. 3 into itself is 3 into 9 is 3. Let's take 3 again. 3 into, you just bring, sorry, you just bring this down, it can't go, then you bring this down. The aim for LCM is such that everything will be brought down to 1. You will divide everything until you get 1. So you keep using any factor that is possible for any of them until they are reduced to 1, all right? Unlike the HCF. So we can now say, therefore, LCM is equal to 1, 2, 3. So 2 times 2 times 2 times 1, 2 times 3 times 3. All right? So 2 times 2 is 4. 4 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 3, okay? 8 times 3 is 24. Is that okay? Then 24 times 3. 24 times 3. 3 times 4. Is that okay? 3 times 4 is 12. Take 1. 3 times 2, 6 plus 1, 72. So this is 72. All right, so that's the HCF, that is the LCM of 12, 24, and 36. Okay, so our correct option there is option E. Let's move to the next. So we have subtract 1101 from 11011. All right, so let's do that. All right, solution. I know why I had to write this down so that you don't get confused. Now, the question says subtract this first from this. So what it means is that this number is being subtracted or should be subtracted from this number. So what that will mean is 1, 1, 0, 1, 1 minus 1, 0, 1, 1. All right? So that's what we are doing. So we are subtracting now. Okay? Remember, this is subtracting in base 2. It's different from subtracting in base 10. All right? All right, so this is 1 minus 1, of course, is 0, also in base 2. 1 minus 0, 1 minus nothing is still that 1. So now, 0 minus 1, okay? So it can't go because this is larger than this. So what we'll do, we take 1 from here. Now, each one we borrow, each one we take. Remember, in counting in base 2, which we have learned, go back to our class, okay? There is a video in this particular platform for number bases. I taught you how to count in base 2. Okay, so when we are counting in base 2, beginning from 0, the next thing is 1, the next thing is 1, 0, okay? So, and these numbers correspond to our what is it called? Our numbers in base 10. So if I say 1, it corresponds to 1 in base 10. If I say 1, 0, it corresponds to 2. After 1, 0, we have 1, 1. Okay, it corresponds to 3, just like that. Do you get the point now? So if I have 2 minus 1 giving me 1, it means 1, 0 minus 1 should also give us 1. Do you understand the point now? All right, so if we take 1 from here and put here, it becomes 1, 0. Okay, so 1, 0, okay, minus 1 gives us 1. Do you get the point now? What is now left here is 0. We'll carry 1 from here, put here, it becomes 1, 0. 1, 0 minus 1 will also give us 1. Okay, so this in base 2 subtracting will give us 1, 1, 1, 0, which is option E. 1, 1, 1, 0. All right? All right. So I want to believe you understand what I want to believe you understand what I explained here. If you don't understand, you can drop a question maybe on the comment section. I may have to just reply you and explain further in the comment section, okay? All right, or you can repeat my explanation again. You should be able to get the answer better. Find the product of 1 0 in base 2 and 1 1 in base 2. Remember, when I'm calling these things, I don't call them 10. Like this 1 0, I don't call 10. So that when you're doing this, you don't say to your teacher that find the product of 10 in base 10 and 11 in base 10. No. 11 in base 10, 11 in base 2 is not even 1 1. There is 11 equivalent to base 2. Okay, which if you check where we did counting in base 2, you will know what the equivalent. It should be something around 1 1 1 0 0, something like that. All right, so it is 1 0 and it is 1 1. It's different from the 10 you know. It's different from the 11 you know. All right. So number 17, they say we should find the product. Product is multiplication. So we are doing 1 0 in base 2 times 1 1 also in base 2. So this is what we are doing, all right? The multiplication you know. 1 times 0 is, of course, 0. 1 times 1 is 1. 1 times 0, of course, 0. 1 times 1 is 1. So the same thing you do for your addition and addition. So 0 plus nothing is 0. 1 plus 0 is 1. 0 plus 1 is 1. So the answer is 1 1 0 in base 2. And that should be option C, 1 1 0 in base 2. I think the worst thing that could happen to anybody solving mathematics is after wasting your time, solve a question and you check for the answers in the options and none of the options carries your answer. It could be so frustrating, okay? But you can bypass those things by being careful when you're solving, okay? But even if you get to that point, all you need to do is go back to your solving, check out for where you probably must have made a mistake and correct yourself, all right? All right, let's move to the next one. Find the reciprocal of 0.65 correct to 3 significant figures. So let's do that. All right, so we have 0.65 reciprocal. Reciprocal of 0.65. They say correct to 3SF. All right, so this is equal to 0.65. You know, there is a popular saying, you know, this thing called reciprocal, it's very easy to understand. There is a popular saying that says respect is a reciprocal. Is that okay? It means that if I respect you, you should be able to respect me. So anybody can be in the position of respect, right? Okay, so, but then let's look at this now, okay? The first thing we need to do, we need to convert this into a fraction, okay? All right, so for us to convert to fraction, because if we don't convert this into fraction, we will not get the reciprocal of it with this. So we'll convert to fraction. To convert to fraction, I just noticed something now, somewhere around, okay, I've cleaned it. So you move this 1, 2, all right? So this is now 65 over what? 100. I can hear you give me the answer there. 100 because we moved 1, 2, right? All right, so reciprocal, just like I explained in that respect, is a reciprocal, okay? 65 is the one carrying 100 now. So let 100 come and carry 65, that is what it means. So reciprocal just means carry the, what is it called? The denominator, and let the denominator now become the numerator. Let the numerator come down to be the denominator. That is what it is, okay? So this will now be 100 divided by 65. Is that okay now? Right? Okay, so we can simplify this. Remember, we need to have this thing because if you check your options are all in decimal number. So we have to simplify or divide it to decimal number, okay? All right. So what we do, simplify this now. 5 into 100, okay? 5 into 100 should give us 20. Is that okay? 5 into 65, 5 into 6 is 1, remainder 1. Put 1 here, it becomes 15. 5 into 15 is 13. Now, when we're doing approximation and estimation, go back to the video in this channel. I can remember I explained something like this. Exactly, not something like this, exactly this question. By then, this exam had not been written. So what it means is that this question was repeated. Just go back to approximation and estimation. You will see exactly something like this. So this question was like probably asked, let's say in 2022 or 21 or 20 or 2020 or 2019 or thereabout. But look at in 2023 is repeated. I can remember vividly. Okay, so if you go back to our lesson in approximation and estimation, you will see where we solved this. You will see where I taught you how to simplify this kind of thing. So we have 20 over 13. We can get this in decimal number, but I'm not going to do that, okay? In BECE, you'll be allowed to use calculator to write your mathematics. So to be fast, okay, just use your calculator and punch this in. You can even punch it at this level, 100 over 24 over 65. So if you do 100 divided by 65, all right? So you have 20 over 13, which is what we say. I want to remove this thing in, let me use another form of calculator. So if we have 100 divided by 65, it gives us 1.5384. 1.5384, and we have other numbers there, okay? That is what it will give you. But the question is, they say we should correct it to what? 3 significant figures. In this, for example, this 1, 2, 3, 4, first significant figure. Not even 4, 5. This 1, 2, 3, 4, 5, because 1 is a significant figure. This 5 significant figures. It means we need something that will take us from here, 1, 2, down to this point. We want 84 and 4 to go out. Is that okay? So 8 is a round-up number. So this will be approximately equal to 1.5. 8 goes off, 4 and 8, they will just move off. But then 8 will add plus 1 to 3 to become 4. All right, so that is the answer, 1.54, which is option number C as the correct option there, right? Okay, let's move to the next one. If 6 men can do a job in 4 days, 6 men do a job in 4 days, all right? How many days will it take 8 men to do the same job if they work at the same rate or at the same pace? Do you understand the point? All right, let's see that, number 19. 6 men, they did this job in 4 days. 6 men, 4 days. So 8 men, how many days? We don't know. Now, to know how many days it will take 8 men, you ask yourself, 6 men, 4 days. 6 men, 4 days. How long will it take 1 man to do a work that 6 men did for 4 days? So what it will mean is that if we multiply these 6 men by the number of days, that is what it will take a man. So it means 1 man will do that work in 6 times 4 days. That is, he will do it in 24 days. That is what 1 man will take to do it. Do you understand the point now? So what it now means is that 8 men, since 1 man does it for, since 1 man does this work, with just 1 man in 24 days, how many now will it take 8 men? It will be this 24, so 8 men will now be 24 over 8, which is equal to what? 3 days. All right? So 3 days. The option there is option B. It will take 8 men 3 days. If 6 men can do it in 4 days, it means 8 men will do it in lesser time. Do you understand the point now? This is an inverse proportion. Okay? The higher the number of men for that job, the lower the time they will take to execute it. Do you understand the point now? All right. But the fewer the number of men, the higher they will have to complete the job. Do you understand the point now? Okay, just like if you and your sibling, they give you to do house chores. Okay, you and your siblings will do that work faster compared to if you're doing it alone. Is that okay? All right. Okay, so let's look at the next question, number 20. The ratio of boys to girls in a mixed school is 4:5. Ratio of boys to girls in a mixed school is 4:5. So let's look at that. All right, so they said the ratio of boys to girls in a mixed school is 4:5. So boys, so this is number 20, right? So boys is to girls is in the ratio of 4:5. All right, so they said if there are 375 girls in the school, 375 girls in the school. Now they're asking how many are the boys? How many are boys? Okay, question to guess. How many is equal to boys? All right. Okay, so let's look at this now. Okay, they said that the ratio of boys to girls is 4:5. It means that 4 is for boys, 5 is to girls. Actually, in this school, from the ratio, you can tell that the number of girls is larger than the number of boys. So if the number of girls is 375, in your option, just know that the answer you will get should not be greater than 375 because boys, okay, their ratio is smaller. So let's look at this now. All right. So if we look at the first thing we should ask ourselves is, what is the total population of the school? What is the total population of the school? So we need to look for the total population of the school. That is it. And we can get the total population of the school since we know the total population of the girls. Do you understand? And we know the ratio of the girls. So the first thing we do is total ratio. The ratio gives us total ratio, first of all, is equal to what? 4 plus 5, which is equal to 9. All right? It means that girls, okay, it means that to get the total number now, total will now be ratio of girls, which is 5 is to the total ratio 9, okay, times the total number. Let's just say, let the total number of students, the number of both boys and girls be y. Let it be y. So this means that 5/9 of y, that is times y, they say is equal to what? 375. This is for girls. We are using the ratio for girls. The ratio of girls of the total number gave us 375. Do you get the point? So we need to look at what this is now. Okay? So this is 5y, because 5 times y is 5y all over 9 is equal to 375. Okay? This is over 1. So if we cross multiply, this will be 5y is equal to 375 times 9. All right? So this will mean if we divide both sides by 5y, this will be 5y all over 5, 5y over 5 all over this over 5. So this removes this. Y will now be equal to, okay? So let's see what we have here, okay? 5 into itself is 1. 5 into 37 will give us 7 remainder 2, all right? Because 5 into 35 is 7. So it will give us 7 remainder what? 2, all right? That we add it to 5, it becomes 25. 5 into 25 is 5, all right? Do you get that now? So this is 375 over 5 is 75, so times 9. So the total number of students will be equal to 75 times 9. Just like I said, you can make use of a calculator in your exam hall. They will allow you to do for BECE exam, okay? So you do 75 times 9. So it gives us 675. So 675 students. Now, see how tricky these people can be. Your option E is 675. You can just go ahead and now pick that answer and you will fail it. The question is how many boys, not what is the total population of the students. The question is how many boys. Okay, so since we have gotten the total number of students, 1, and we have the total number of girls, what do we do to get the number of boys? Is to simply subtract the number of girls from the total number of the students, and we have boys. So it means that boys will now be equal to total minus girls. Is that correct? So that will mean 675 minus 375. Okay, so that will give us about 300 or so. Okay, so 675 minus 375. So that gives us 300. All right. Okay, so this is 300 boys are in that school. Why 375 girls are in that school? All right, so our answer is option B. We'll move to the next now.